Hello Year 13, this is the first lesson on the normal distribution. So today we're going to have a look at an introduction and work towards exercise 3A. So you should find the notes in the Google Classroom and hopefully you've had the chance to print them off. If not, work from the screen and work onto paper. So we've got the what you should already know section, which is well worth taking a few minutes to work through this. So it gives you a little recap on what we already know from the first book. On the binomial distribution and a little bit of work on hypothesis testing. So if you could just pause the video and work through those questions and then come back for the answers. Okay, so the what you should already know answers. So the first one is 0.540. These are three significant figures and part B is 0.390. For question 2, you can either use a calculation or just stick it in your calculator. You get 0.124 to three significant figures. And for part B, you get 0.584. And for part C, you're doing less than or equal to 10 minus less than or equal to 2, which gives you 0.869 to three significant figures. Question 3. We're looking at a binomial distribution. The probability that x equals 2 is 0.211, and for part B, less than or equal to 3 is 0.599. Okay, so those are what we should already know. Let's move on now and start looking at the normal distribution. So what you will learn in this chapter. So this is for the whole of this chapter in book 2. And it just sets out what we're going to find out and what we're going to learn. So today we're going to be looking at the characteristics of the normal distribution, what shape it is, what parameters it has, and then start looking at using it to find probabilities. So for example, given that an IQ is distributed normally, hold on, my pencil's charging up. So x is distributed with a normal distribution. So previously we've only used binomials, so now m for a normal distribution. And these are its parameters, and I'll explain what they are in just a moment. Determine the probability that a randomly chosen person has an IQ above 130. So that's kind of where we're going to get to, and you can have a read through that. Okay, so important, starting here. In previous work, you calculated probabilities for discrete random variables. We were working with the binomial distribution. There's another class of random variables called continuous random variables. And probabilities for continuous, I seem to be struggling with words today, continuous variables are calculated by finding the area under a graph known as the PDF, the probability density function. Here you will look at just one naturally occurring continuous distribution, the normal distribution. And I know we've talked about the normal distribution before, so just, in case you can't remember, I'll just do a very quick explanation. So if you imagine that you were able to go out and measure all the leaves on all the oak trees in all the world, and what you're going to have is you're going to have a mean value, which is around here. In fact, the mean, the median, and the mode would all be the same. That's not a very good picture, is it? Let's take that. Okay, so it's more around about there. So you've got most things are at the mean value, and then you've got a lot. If you imagine this is frequency, you've got a lot that are a little bit higher and a little bit lower than that mean. And then up here, you've got really, really big oak leaves, and there's very few of them, and really teeny ones, and there's very few of them, and it uniformly will spread out. Same if you took the heights of adult males in the world. You've got a mean. Oh, you've got a mean here. Sorry about that. You've got a mean here. You've got lots that are a bit less, and there's getting fewer of them and fewer of them. And outside here, you've got very low numbers. Okay, so it's naturally occurring distributions. Now, the normal curve. Normal distributions are a family of distributions that have the same general shape. It's this bell shape. They have a distinctive bell-shaped curve. They're symmetrical, with scores more concentrated in the middle than they are in the tails. It's often illustrated by a diagram which highlights the difference in shape between mean and standard deviation. So take this one, for example. These are both the same spread outness as each other, okay? So these two have both got the same spread or the same dispersion, yeah? And we measure it with variance. Remember standard deviation and variance? So they've got the same variance, but they've got different means. So this one has got a lower mean than this one. Whereas this diagram here, they've got the same dispersion, they're the same spread out. Sorry, they've got the same mean rather, but they're differently spread from each other. Yeah, one's there and one's there. Okay, imagine the area under the curve was the same for both of these, so that one's more spread out. So same dispersion, different mean, same mean, different dispersion. And there was just lots of different normal curves there. They're all normal curves. Okay, so the total area under all the curves is equal to 1. Okay, so that means that underneath here, if you added up all the probabilities, one of them would happen. One is certain. Okay. Right, so it's symmetrical about the mean. I've said that before. That's this value here. Let's pop it in. There's our mean. Okay, mu. Mu. Draw it like that. I'm sure we've had it before. So the mean and the median and the mode are equal to each other. The total area under the curve is 1. And the shaded area, in this case, if we could work out what that shaded area was, that will give us the probability that x lies between these two values a and b. So that portion would tell us that. We say that the random variable x is distributed normally with mean value mu and variance sigma squared. And these are the parameters of the distribution. So remember, this is the standard deviation. So square the standard deviation, you get the variance. So the parameters for a normal distribution are the mean and the variance. They're always written in that order. So let's see if we can answer some of these questions. So normal distribution question and answer. For a normal distribution to be used, the variable has to be, and I hope that you pick this up, continuous. With a discrete variable, all the probabilities have to add up to 1. For a continuous variable, similarly, the area under the curve is 1. So to find the probability that x lies between 170 and 190, we could find the blue shaded area. Now, would we ever want to find, for example, the probability that x equals 200? Now, because this is continuous, I'll just explain that down here. Because this is continuous, okay, I was just saying it would be tiny. Because it's a continuous distribution, you're not going to find out, don't need to find out the probability that it is a particular value, because there isn't just 200 and 201 and 202. That would make it discrete. There's an infinite number of values depending on how accurate you can be. So you will not have to find the probability that x equals something, only that it lies between two values. Okay, the curve has a point of inflection at 1 standard deviation from the mean. So that's here. Okay, so this is, standard deviation is sigma. So mu plus sigma is 1 standard deviation above the mean. So that distance from there to there will be sigma. And that is 1 below the mean. Okay. The normal distribution is symmetrical. So the mean and the mode and the median are all equal. We've said that all before. Now, when you think about standard deviations, we need to remember the 68, 95, 99.7 rule. And this needs to be memorised. So this tells us the percentage of data that lies within 1, within 2 and within 3 standard deviations of the mean. So we've got here, there's your mean, okay. 1 standard deviation below the mean is here and 1 standard deviation above the mean is here. That is 34% of the distribution. So within plus or minus 1 standard deviation is 68%. That's the 68 part. Now within 2 standard deviations of the means, that's 2 above and 2 below. You've got 34 plus 14, okay, above, which gives me 48. You've got 48 below, which gives us, well, it's approximately that. That gives us 99. Here we go. Within 1 standard deviation of the mean is about 68%. Within 2 standard deviations of the mean, these have been rounded, about 95%. And within 3 standard deviations of the mean, we're looking at almost all the data will be within 3 standard deviations of the mean, 99.7% of it. So those are the key ones to remember: 68, 95, 99.7. Now here, for practical purposes, we consider all data to lie within 5 standard deviations of the mean. Only 1 in 1.7 million would fall outside of it. So you can pretty much assume that all your data lies within 5 standard deviations of the mean. So here's some examples, and I'm going to keep telling you to draw sketches as you go through, okay? So the diameters of a rivet produced by a particular machine is modelled with this. Find the probability that x is greater than 8, and then the probability it lies between 7.8 and 8.2. At the moment, we're not going to need our calculator for this. So we take a diagram, doesn't matter how rough it is. There we go. Okay. Now this has got mean 8. So that's going to be that value there. Okay. And the standard deviation, and this one is 0.2. Well, you can write those down if you want to. Okay. So we're looking for the probability that x is greater than 8. So that's everything this side. So we can see that's half the distribution. So equals 0.5. That's the probability, half. Right, between 7.8 and 8.2. So that's going to be here, 7.8 and 8.2. I'm just going to zoom in on that for a second. This then here is 0.2. And this is also 0.2. Hang on, I'm just letting the dog in. Quick. Quick. Okay, so that means that we are within 1 standard deviation of the mean. Okay, so remember that's the 68%. So that represents 68%, so 0.68. Okay, number 2. Intelligence quotient for a given population is distributed with this. So let's get a diagram. Here it is. We've got mean 100, okay, and we've got, this is 15, this is 100, and we're going between 70 and 130. So there's 70 and there's 130. That's got a gap of 30 between each one, which is 2 lots of the standard deviation. So 2 sigma there and 2 sigma there. So go back to your previous page to check your results. 95% will lie within 2 standard deviations of the mean. So that's 0.95. And the next one. So take your diagram. And we've got 115 is here, and above 115 will be there. So 15 is within 1 standard deviation of the mean. Okay, so this bit here is 1 sigma. So the area of that bit, just this part in here, will be half of the 68%. So that's 34%, and that is 50%, isn't it? Because it's half the distribution. So altogether, that lot is 0.84. So therefore, the rest of it in here must be equal to 0.16. Okay, so that's the kind of questions you'll be answering in exercise 3A. Let's have a try at this one before we go off. So the masses of the pigs, m kilograms in a farm, are distributed normally like so. 84% of the pigs weigh more than 52 kilograms. So the probability that m is greater than 52 is 0.84. And the probability, so 97.5 weigh more than 47.5 kilograms. So the probability that m is greater than 47.5 is 0.975, we've got to find mu and sigma squared. So we're working backwards on this one. All right, so let's draw the information that we've got. So I've got some value mu here. And we know the probability that's greater than 52 is 0.84. So that's going to have to be down here somewhere so that we can produce this 0.84, which is obviously more than a half. Let's draw the other one as well, and then we'll gather our information together. So again, we've got mu, and this time we've got 0.975, so a bit further along, 47.5 there. And this area here is 0.975. So let's just check about those two special numbers, okay, 0.84 and 0.975, okay, 0.975 and 0.84, okay. Well, this bit over here, let me just get my pen, yeah, that bit there is going to be 0.5. So in here, we're going to have 0.34, okay. So if that bit's 34%, that's the same as this bit here, which means that it's 1 standard deviation below the mean. Okay. 1 standard, sorry, dog again. Right, 1 standard deviation below the mean. So mu, take away 1 standard deviation, must be equal to 52. So that's what we can get from that diagram there. Okay, sorry, this diagram here. Right, let's look at this one. So this bit up here, I'll colour it in again. That bit there again is 0.5, which means that this side of it is 0.475, okay, which is half of 95%. So that's 2 standard deviations. So this distance here is 2 sigma. So mu minus 2 sigma is 47.5. So what you've got there then is a pair of simultaneous equations. You can use your calculator to solve them, or you can do them by hand. And what you'll end up with, I hope, is sigma is 4.5 and mu is 56.5. Okay, I did it by hand there, but whatever you like. Okay, right, so that takes you to the exercise for this section, which is 3A. So work through that. Obviously we've already done question 7 there, so it shouldn't take too long. Okay.